Hey everyone, welcome to another video by Pythonpool. In this video, we're gonna see sorting algorithms in Python. First of all, we'll be learning about what is sorting and why do we need it in real life. So what is sorting? Sorting is just a basic building block, or you could say arranging the blocks on which algorithms are built upon. So when you need a data to be sorted, so just you could process with other functions. So sorting is basically the most basic thing you could ever do with your data that could produce an outstanding result. Okay. And why sorting? Why do we need sorting? Okay. First of all, if we want any searching, if we want any particular data in our whole data set, we find easier to search that data. Even we find easier to eliminate the duplicates in the data by sorting. Imagine you need to remove all the duplicates present in the list. So what would you do? You would first sort the list and you would see which duplicate element you need to find. And then you would just refer to the middle of the list or beginning of the list or end of the list, depending upon your list data and your requirement data. So searching and removing the duplicates are very easy with sorting. We could also see selection as a criteria, which is very important in our day-to-day life. According to your values and all the specifications you could provide, all the dedication to your works, you are ranked between them. You are ranked according to them. Okay, so selection could be the criteria where a sorted list is in front of you, and you need to select the data from that. It's easier to be it's easier to find the list as sorted. That random list is present before you. You don't know where to find your number, where to select that number. You just get confused. But in a sorted list, in a specific manner, you know how could you proceed further. And of course, a distribution, all the frequency distribution according to your selection criteria, according to various factors which we consider during distribution, is easier with sorting. Python has built-in sorting algorithm. Python has built-in function named as sorted, which would sort a data set, which would sort an array or list for you. That is always present in Python. But the problem is, you could see a live example. If I have a list named as capital L1, and if I create a list named as small l1 that is sorted of the list of capital L1, you would see the output as a sorted list. This could return us the sorted result, but the question arises: why do we need sorted algorithm then? If the Python initially has their built-in sorting algorithm, why do we need another algorithm for our programs? The main reason is because of time. In this fast-paced world where India is planning to have 5G, you cannot wait your program for a second, even for a second. So you need most advanced, most efficient algorithms to run your programs. And we developers have designed various of these algorithms according to our needs. The most common of all is the bubble sort algorithm. It is the most common and the simplest algorithm, and this is the algorithm we're gonna discuss today. So what is bubble sort? As the name suggests, it pops the bubble and replaces them. It may be a bit confused to you, but when I'll implement the algorithm and I will explain you with an example, you would rather find it easy in comparison to other algorithms. Okay, what it do, it start checking your list from the very beginning, and it checks the two indexes, index 1 and its consecutive index. So preceding index and the consecutive index, it compares them, it compares their value, and if the larger value is at preceding index, it swaps them. And if the condition doesn't satisfy, that if the larger value is not present in the preceding index than the consecutive index, then it doesn't swap. It just jumps to another consecutive pair of elements. Okay. So what bubble sort does is it swaps the data according to their according to your size, according to their numbers, according to their values. And once the whole list is being sorted, it prints that. Okay, let us understand this with an example. Let me code a program. Let me name it as test.py, and we'll be defining the code for sorting algorithm today. That is bubble sort algorithm. First of all, we need a function. Name it as bubble sort, and we'll be defining our algorithm in this. It will take a list of numbers. We'll be giving a list of numbers. First of all, we need a variable, name it as n, which would store the length of this list. So our looping would be easier. And now we need to run the loop for I in range of n. So we'll be running the I loop, first loop on the whole. Okay, it's not, it's n. We'll be running the whole loop over the list. And then what we need to do, first of all, we need to select first item. And we will compare that first item with the whole list. Let's see if the greatest item is at the first place. It need to compare with the whole list, and it need to be set at the end. So first of all, what we take ith zeroth position of the item which is present as zeroth position. We'll be comparing it with the whole list with another loop, and then when it is present it at its correct place, we'll be jumping to the another element in the list, that is I equals to first position. First of all, we need a boolean variable, name it as sorted. If our list is being sorted, then we need to break this loop. So we would need this sorted boolean variable. Okay, we have selected our zeroth position. Now what we need to do, we need to compare that zeroth position with the whole list. For that, we'll be defining another for loop for j in, and it will be running from in the range of n minus I. It would be running in the range of n minus I. Since I is from 0, I is starting from 0, so it would not have any impact for the zeroth position. So we'll be adding -1 here. Okay, so what we did, we take first element from the ith loop, and then we'll be comparing that first element with the whole list. And how will we comparing? If the L of j is greater than L of j of +1, that it is greater than its consecutive number, then it should be placed after that number, right? So what we need to do, if this condition satisfied, what we need to do, we need to swap this. And fortunately, Python has very easiest method of swiping, that you just name those variables, just give the names of those variables, and n equals to swap the values of those variables. That is, if I give the order of Lj and Lj plus 1, then after equals to, I'll giving the order of Lj plus 1 and Lj. And what it will do, it will store the Lj plus 1 value in the Lj variable, Ljth position, and Lj value, that is I'm giving Lj value in the Lj plus 1 variable. That's the easiest method in the Python for swapping. And if this condition satisfied, do this, and once again sorted becomes the false. So sorted should be in that position, sorted should be false. Okay, once you run this loop, it should be false. Then once again, if the condition satisfied, then it should be true. Then once again, if the condition satisfied, then it should be true. As many times as you run the loop, it would satisfy the condition and it would set the sorted as false. Okay, and if the sorted, fortunately, if the sorted becomes true, if the list is being sorted, if sorted, I don't need to write true here, that because Python will understand. If the sorted becomes true, if it becomes sorted, then what we need to do, we need to break this loop. Which loop? We need to break this I loop. So I am placing this if statement inside this I loop, because we have taken the ith element, we have compared with the whole list, and we cannot find any match for the swapping. That means the list is being sorted. So we need to make the sorted as true. And if the sorted becomes true, then we need to break this loop. And after breaking this loop, what we want from this function, we want to return that list. So all the changes made in the list, we want to return that. So list is L, so we need to return that. And now just give the arguments to the function. First of all, I define the loop. Let me define it as Li, and I'll give the output as A2. My output is specific because I have demonstrated it using a presentation. You could give any output, that's totally your choice, because I have given the specific output because that would be easier for you to understand. The values will not be mixed up. Okay, I have defined the list. I need to call this function, and this function is returning something. So I should have one variable which would store the result. I'll name the variable as res, short form for result. I'll call this bubble sort function and I'll pass the li list here. And whatever it returns, it should be stored in this res, and I need to print this res. So once I save this program, once I run this program, you see this list. I'll make it visible so you could compare that. I hope this list is clearly visible to you, so you could compare the result. Okay, and I'm going to run this program, python test.py. It is printing us the reverse result. Let's see where we made a mistake. Okay, this should not be less than, this should be greater than. I'm so sorry for that one. And now if I correct that one and if I run my program once again, you could see we got the result. I'll show the list to you so you could compare the result. That's perfectly the result we want. Let's understand what bubble sort algorithm does in this case. What it does, now this was our list. This list we gave as the input. First of all, what it did, it take 8 as the ith position and it compares with the 2. If 8 is greater than 2, then what it will do, it will swap them. And then it will compare it with another element in the list. If it is greater than 1, then it will swap them. Once again, if it is greater, then it will swap them. Once again, if it is greater, it will swap them. Now, right now, our most smallest number is present at the zeroth position. It is the intermediate position where our list is partially sorted. Now, our I would increase, and now it would compare, instead of comparing with the zeroth position, now our loop will be comparing it with the first position. That is initially second position. So it will compare 6 with 4. If it is greater, it will swap. Once again, 6 with 5. If it is greater, it would swap. And once again, it would compare with 8. If it is not greater, any change wouldn't be happening. Once again, it would jump to the 5. So second position, it would compare with 6 and 8. They are perfectly fine. Once again, with the 6 and then the 8. If they are perfectly fine, this is our finally generated list. This list 82645 unsorted list we gave as the input, and this list we gain as the output. That is sorted list. This could be obtained with the sorted function that is built-in function in the Python, but it would take more time to generate this list. Initially, when you give the small list, you don't feel that much time to generate the output. But when you are dealing with the largest list, like if you want to generate a list of numbers which would range from 0 to 1 lakh or 0 to 1,000 lakhs. So that would take comparatively more time than the bubble sort. Okay. Now I'm going to discuss about the advantages and disadvantages of bubble sort algorithm. Okay. If the bubble sort algorithm is so much good, then why don't we use it every time? We don't use bubble sort algorithm every time. That is because our bubble sort is simplest to write, but it is the slowest of all. The algorithms which we designed for our programs, it is the slowest of them. So we don't use bubble sort more efficiently, more frequently. That's just a simple introduction for you, so you would understand what is sorting, and you are just new to sorting, so you'd understand with the simplest example. Proceeding higher, we'll be jumping to the more complex algorithms, and that would be more faster than this bubble sort algorithm. So that's it from this video. I hope you like this video. Have a great day ahead. Thank you.